So to start, I want you guys to draw this XY axis like this. Here's our 0 degrees. This is going to be true for the whole class. Think of this x-axis on the right. That's where we're going to start for all our angles. And the way it's going to work is if you rotate up first or counterclockwise, that's considered a positive rotation. If we rotate down first or clockwise, that's considered a negative rotation. So if I were to keep going in the positive direction, this would be 90, 180, 270, and 360. If you were to go to the negative direction, this would be negative 90, negative 180, negative 270, and of course negative 360. So let's go to our first example. It just says draw an angle, 45 degrees. So to make it easier, I'll just draw your XY axis like this. And then you can actually use the x-axis as like the first side. And then, so leave that there. And then rotate your other leg up 45 degrees. And there's your answer. So a couple of vocab words we're going to add here. This is often referred to as the fixed side. Sometimes some books call it the initial side. Essentially, we like to use the x-axis because it makes everything a lot easier. And then this leg right here, that's often referred to as the terminal side. So think of that as just a leg that's rotating. So for our next example, let's go to negative 90. So start by drawing your XY axis again. Here's your fixed side right there. Rotate negative 90, it's going to be down first. And there's your answer. Let's go to 225. So again, here's your XY axis. And then 225, think about that, where that would be. This is 0, 90, 180, 270. 225 should be right in the middle of quadrant 3, right there, because think of that as like 45 past 180. So that would be your 225 degrees. And the last one, 405, this one's interesting because it's clearly over 360. So if you think about this, it's going to rotate one full time, and think about how much is left. If you actually were to do 405 minus 360, you get 45 degrees, which means this goes up 45 degrees more. And there's your answer. Next example. Converting from degrees to radians. So everybody highlight this word, radians. This is clearly a new vocab word. I don't think any of you have learned that yet. So I'm going to define that for you right now. So the definition is right here. A radian is the angle formed by laying one radius unit on a circle. So I'll show you that right here. I'm going to draw a circle right here for you. Let's say the center is right about here, and then here's our radius. I'm going to try to do it to scale. I'm going to grab that radius, and I'm going to say it's right about here. That would be R. This angle we just created, right here, that is 1 radian. And just that symbol, just this symbol is pronounced theta. You'll see this throughout. But again, the angle is about 1 radian. And if you look at this picture, this appears to be about 60 degrees. And that is actually true. So if you hopefully drew it to scale, you can see that it is about 6 degrees. Clearly not exactly, but it is roughly 360 degrees. Now the reason for that is because if you were to keep going, let's say make 6 of these, notice how that would mean 6 radians is about 360 degrees, which means you should be able to take the radius and go around a circle 6 times. And you knew that from geometry because look at this formula. Circumference is 2 pi r, and this number 2 pi is about 6. So circumference is about 6 times the radius. So that's what we're saying here. So in short, here's your little cheat sheet. 1 radian is going to be about 60 degrees. And then here's the ending. 2 pi radians is exactly 360, which means 1 pi radian is exactly 180 degrees. Okay, so put a box around that. So that's just some concept. We're going to use some basic conversion to figure these problems out. It says convert each angle from degrees to radians. So simply take your 60 degrees. The one we use the most is going to be right here. So you guys can highlight this middle one right there. So you just write 60 and multiply it by the conversion factor, which is going to be pi over 180. Since pi radians is 180 degrees, the degrees cancel out. That reduces to 3. So now we have pi over 3 radians. You can write radians, but this is actually the one time in math and science where you don't even need a unit. If you're to write pi over 3, it's assumed to be a radian. So you can have it there or not. Either way is fine. Next example, 150. So again, multiply it by pi over 180. We reduce everything by 30. So that's going to be 5 pi over 6. Negative 45. Again, this is pretty repetitive once you know what to do. Multiply by pi over 180. You reduce it. That's negative pi over 4. And this one's interesting because it looks really hard, but you'll realize that nothing reduces, so just cross out your degrees and then you're done. 107 pi over 180. So in short, I'll put this in red. If you're converting from degrees to radians, simply multiply by pi over 180. And I'll 3D box that for you. So we know that's super important. Then we can write conversion tip. So our next part is going to be going the opposite direction. So we have pi over 6 radians, so multiply by the reciprocal, 180 degrees over pi. And again, you can write radians, but it's not necessary. These cancel out. This reduces. Your answer is 30 degrees. Next one, negative 3 pi over 4, multiplied by 180 degrees over pi. The pi's cancel. We reduce that to 45, negative 135 degrees. Next one, 7 pi over 3, multiplied by 180 over pi. Your pi's cancel. That reduces 420 degrees. And this last one's interesting because it says 3 radians. So notice how there's no pi. That's okay. Just write your 3 there and multiply what you've been multiplying by, 180 over pi. Notice how nothing happens. You just get 540 degrees over pi. That is your answer. You have to remember that pi is just a number. It does not actually imply anything. A lot of people think that pi implies that it's a radian. That is not true. Pi is just a number. And that number, as you all know, is about 3.14.